Hello everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on group anagrams. Our problem states that we are given an array of strings and our task is to group all anagrams together. The order of the groups doesn't matter. So for the brute force approach, the idea is to maintain a list of groups, and for every string, we will compare it with the first string of each group. We will use the valid anagram logic which we used yesterday, and if it matches, we will add it to that group. Otherwise, we will create a new group. For that, let's initialize a list of list for the output as a result. And for each string, string yes in strs. Initially, let's consider it is not added. Is false. So for each group in the result, let's check if it is anagram. Group will get of 0 and yes. If it is true, then we would add it to our group. And we would make added as true and we would break. Now, after coming out of the for loop, if added is false, then we will create a new group. And we will add it to the new group. Yes, and we will also add it to the result. At the end, we will return result. Now, we also need to implement this is anagram method. So for that, the return type is boolean, is anagram, and we are passing two strings, let's say string A and string B, and simply we will check the lengths. If they are not equal, then we will return false. Otherwise, we will create one frequency array of size 26. And for each character in A, we would increment the index. And for each character in B, we would decrement the index. And again, we will check the count. For count and frequency, if it is not 0, then we will return false. Otherwise, we will return true. Let's run the code. It is working. So here we are repeatedly checking for anagrams which can cause unnecessary comparisons. So for this we need to find out and think of an optimized approach. For this we can use hash map plus key, where all algorithms where all anagrams share the same frequency pattern. So we will convert each string into a key and we will use that key in a hash map. So two ways to build are, we would sort the string or we would use a frequency array key. We would use sorted string for some clarity. Let's comment on the previous code. Okay, now we need a map of type string and the list. Called map. So for each string, strs, let's convert it into char array. The chars are yes dot to char array. Okay, now let's sort this. Okay, now we will convert that into string key. Now we'll put it in map if it is absent. Map dot put if absent of key and the new array list. And then we will get it from the map. We'll get the key and we will add yes. So at the end we will return new array list of map.values. Let's run the code. It is accepted. Let's submit it. Cool. So here the time complexity is n into k log k, because we are sorting the keys. And for the dry run, if you consider this example 1, the word eat is sorted into AET. So this would go to group 1. T is also sorted to AET. So this will also go to group 1. And ATE is also sorted to AET. So this will also go to the same group. Likewise, we will sort and all the similar words are moved to the same group. So the common mistakes here we do are, we will forget to convert the sorted character array into the string, and we using list as map key, and we would also confuse valid anagram with group anagram. So the final takeaway is, valid anagram checks for 2 strings, but group anagram scales that idea using a hash map. So yeah, that's it for today's problem, and I'll see you in the next one.